generated on a mid-temperature level. That means about 250 to 300 degrees, not just 100 as with thermal collectors usually. And that provides enough energy for running all thermal energy services from the collected heat. And by doing so, we can also minimize the conversion losses that are usually associated with the transport and also with the conversion of energy. If you run a generator, for instance, only 1/3 goes into electricity, the rest is waste heat. Not so if we go with solar power, with concentrated solar power. So we just focus the solar rays, and then we can harvest temperatures of up to 600 degrees right on the spot. And that is a very simple solar cooker. You can do that in your garden. Just it's a bit inconvenient because you have to track the sun manually. So that is something that you wouldn't want to do in a household every day, but for a barbecue party it's quite some fun. And then we developed a number of prototypes with students. How can we improve that process? How can we go along in terms of making that suitable for a normal household and making that also convenient? And there are a number of devices already available. Think of an absorption fridge, which is now running by gas flame, but it can be easily operated by hot thermal oil, which was heated by the solar concentrator and then transported by a pipe to the fridge. So that means you can operate the fridge without electricity. And the same goes for the cooking. You can operate a cooking plate with the hot thermal oil, and again saving a large share of the electricity. And in the end, even the remaining electricity demand can be generated from the temperature difference of the 300-degree mid-temperature storage and the ambience temperature via a so-called Stirling engine. Stirling engine is not a new technology. It was developed at the end of the 19th century, but it has been simply forgotten due to the cheap oil price. But it is quite a useful appliance for this wireless house concept. And then of course you need a tracking system. Here we did a prototype for such a tracking system that would follow the sun automatically. And what you see here is a very primitive one, and it's only done from materials that you can really find everywhere. So in every barangay you would find people who can build that thing once they have the blueprint in hand, because all you need is some welding skills and some pipes and some bicycle parts and maybe some car parts for instance the wheel bearings we use here. So that can be produced very cheap and locally, and that also makes the difference to the solar panels, which cannot be produced locally so easy. And our vision basically is to establish demonstration houses, demonstration buildings as well in Europe, but also in Southeast Asia, especially in the Philippines, where we're just upon to start a project with the help of the European Commission under Europe Aid, and that is called the Zero Carbon Resort. Zero Carbon Resort. And the idea is that we want to build energy autonomous resorts by these appropriate technology solutions. Okay? And why the tourism industry? Because it is very close to what a household also needs. That's why it's relevant for households as well. And the model case that we are going to start is going to happen in Palawan. Palawan is the frontier. They have the SEP, the Strategic Environmental Plan, which they are implementing, and in this sense the mindset is already prepared for environmentally more advanced solutions. And we find a lot of resorts there, and most of them have even problems with access to grid connection because they are in remote areas. So we find a good matching with a high availability of solar radiation as an energy source, and then also a need in remote areas for what we call the wireless house. and that will be not only demonstrated in some kind of a flagship model that will be open to the public, so you can actually go there and have a look if it works and how it works, but it will also be distributed to basically resorts and hotel owners, so that we can replicate that in the large scale. And parallel to that, we will run a capacity building program with local authorities, with experts, with architects and engineers, and then trying to make it the more normal development plan, and also spreading out to the residential areas. So once people would acknowledge that there is such a technology in place and that you can actually do something with your high energy bill, then they will certainly want to adopt that. And on top of that, as I've already mentioned, there will be a number of key components that can be produced locally. So raising the availability of this technology and not having the need of importing solar devices. To show you that the idea is maybe older than you think, I would like to show you this picture. What you see here is a solar concentrator. And this solar concentrator, differently from the ones that you've seen before, is not new, but it was presented at the World Exhibition in Paris in 1867, more than 140 years ago, by a mathematics professor at the World Exhibition in Paris. His name is Mouchon, Professor Mouchon, and he was concerned about the availability of coal on the long run at the very beginning of the Industrial Revolution. And at that time, they already thought about, why don't we harvest the rays of the sun to supply our energy demand, especially when it comes to buildings. Unfortunately, at that time, he was a little bit too visionary and he has not pushed through with his ideas. But at least now, 140 years later, we should go and do the things that are already available on a technological and scientific level, and then really put them into practice and cleaning up the building industry when it comes to energy consumption. So our long-term vision is that the building is no longer an energy consumer, but basically an energy producer that can sustain itself plus some surroundings. So that is the vision for the architecture of the future, to my understanding.